going to talk about the margin of error. We're going to go talking about statistics and surveying things, okay? So one of the things I want you to know, like you want to be, when you take a survey or when you read a report about a survey, you want the survey to be unbiased, okay? So let's just say that I was all like having an argument with someone, okay? What's the topic I could argue about? What's the best something? Okay, football. What's a good team? Give me. Raiders are better than Broncos. Who's into Raiders? Who's in the Broncos? Okay, cool. All right, here we go. So let's just say I was in an argument with saying the Raiders are better than the Broncos. Okay. Let's just say it's me versus David. Okay, David. Me versus you. Raiders versus Broncos, okay? I'm saying Raiders are better, okay? And I'm like, Raiders are better, and we're in an argument. I'm like, I bet you if I survey people that everyone's going to love the Raiders more. And then I'm going to not be random. I'm going to be very sneaky and survey people that I know like the Raiders. For example, let me prove my point, David. Zach. Oh, I feel bad now. Here, pull up a chair. Or sit wherever you like. Okay, Zach, Raiders or Broncos? Yeah, see? Raiders, duh. Vic, Raiders or Broncos? Yeah, see? 100% of kids love Raiders. So your Broncos suck. Right? What was wrong with my survey?
You're cheating.
It was biased. I was cheating. That's right. So can you take a look, please?
Not greater. I really make all I can picture is like a bunch of guys like your parents.
So how do I prevent something from being biased? Okay, so how do I prevent something from being biased? How do I prevent someone from cheating on a survey?
You go ahead and go up to strangers, maybe.
How do you do that, though?
You say, hi, do you like the Raiders or the Broncos?
Okay, so randomly to a stranger, and you said the word choose randomly. That's exactly right. So when we choose randomly, then we're able to be unbiased, okay? So that's the first thing, is biased or unbiased, okay? The next thing I want to talk to you about is a margin of error, okay? So let me talk to you about... okay, so the next thing is margin of error. So let's say I wanted to know, like, let's say I had my shoe company... Let's say at my shoe company Rinks Kinks, right? Like Kinks, but with a Hawaiian K. Okay, and I wanted to find the average shoe size. Okay, so I'm like, I want to know what the average shoe size of my market, all of San Dimas, because I'm only gonna sell to San Dimas kids. Okay, so I'm like, I'm gonna pick someone random. Okay, what's your shoe size? 7. Okay, so I just picked. I just sampled her randomly, okay, right? And I sampled one person, 7. So the average is 7, the size 7 of all the campus.
But I don't think that's how it works.
So talk to your neighbors why that does not work. Okay, go.
Okay, I thought you were just saying that. Wait, can we take the average of the shoe size?
Think about what would be the best method.
Can we do the average for a long time? We'll talk to the
You could talk right now. Talk right now. So, is there something wrong? Is there something wrong with that method?
You have to add, you only asked one person.
Okay, what was wrong with my method?
You only asked one person.
Okay, good. I only asked one person, right? Okay, so clearly that's not a representation. There's a huge error because what do you think the smallest shoe size on our campus is? What size was the smallest? You think?
Size 4.
Maybe a 5, a 4, a 6, maybe around there, right? What's the largest shoe size on campus?
Probably like a 16.
12, 16, 14, okay.
I know 15.
Okay, so how many numbers off is 6? Wait, you were 6, right? 7. How far is 7 off from 5? 2 numbers. How far is 7 off from 15?
That's 8 numbers.
Right, it's a huge margin of error, right? So how do you think I would reduce my margin of error?
You get more data from people.
Good, okay, so then I'd ask everyone in this class, I'd be like, what's your shoe size? Your shoe size.
7, 6.
Okay, let's say I just do it for the whole class, and the average I figured out was, for this class, was 10, okay? Or 9. Let's just say average is 9, okay? Okay, I'm trying to run my shoe company for all of San Dimas High. Is average size of 10, we'll just go use 10. Is the average size of 10 that I calculated from this class, all the data, because I have about 30 kids in here, is that an accurate representation of all of San Dimas? Why or why not? Talk to your groups. So, is me sampling 30 kids in this class and getting an average of 10?
No way.
Is that better than just asking one person?
Oh,
Yeah,
that's
yes.
way it is.
Good.
Sorry.
Is it a representation of the whole campus?
No way.
No, what's wrong with it?
This is one class. There's tons of classes out there.
There are tons of classes, right? Okay, that's right. What's wrong with this class?
We're a little dysfunctional.
Okay,
Wait,
like
isn't
half
here?
the kids are missing.
There's a lot of
What kind of kids are missing?
the
Smart
smart
kids.
ones.
The kids. We're talking about shoes. It doesn't matter if you have a smart brain or a less smart brain, right?
Why are
I'm talking about shoes. What kind of kids are in here? Raise your hand. Okay, let me help you out. Raise
There's
your
more
hand if
boys. There's more boys.
you're. Okay, that's part of it. Raise your hand if you're an upperclassman, like 11th or 12th grade.
Oh, me.
Oh, I am.
Oh, okay. Raise your hand if you are a lowerclassman.
Uh-oh, they have little baby feet.
Okay, so I got a question. San Dimas High School. Just now, I realized that there is it's disproportionate here. Wouldn't you agree that there's pretty even amount of 9th, 10th, 11th, and 12th graders?
No
Right.
way.
Pretty even. It's pretty
Wait,
close.
oh, in this class?
No, in all of San
Oh,
Dimas.
yeah, okay, yeah.
So what's wrong with the representation in here? Is it give me an even
It's
representation?
not even, no, it's very uneven.
Okay, so what should I do to get a better average for my shoe company?
Round up everybody in the school and count them off.
Round up? What do you mean? Oh, like round them up like a bunch of cattle?
Yeah, it'd be like, get.
Okay. Yeah, the best thing to do is ask as many kids as I can. Okay, if I could send survey all the students in all of San Dimas, that's called a census. Okay, when you survey everyone, that's called a census. Raise your hand if you've heard of this, the U.S. Census every 10 years. Okay, that's when the government takes a survey of every person that lives in the U.S. They literally send a letter to every house, and they literally have people that are hired to go find homeless people. No joke, because they're citizens. They'll go to the streets, they don't have a home, and they're saying, how old are you, what's your race, ethnicity, and I'll ask all these questions, because they want to sample every possible person, whether they have a home or they're homeless. Does that
Do they
make
give them
sense?
food or anything, or they just say like, let me
They
get
might
your-
give them like a little thing for their time.
Yeah, because that'd be messed up. Like, let me know about you, and then I'm gonna leave. Have a nice evening.
Right? Why do they get a census? Why do you think they want to know everything about everyone?
So they,
What are we talking about today?
for maybe an
Error.
Error, right? What happens when you ask everyone? You do a census. Will you have any error?
No.
No. Does that make sense? Right? What if I asked every student here on campus what their shoe size was? Will I have any error in my data?
No.
No. You see that? Did I have error in my data by asking just one person?
Yeah.
Was it a big margin of error?
Yeah.
Huge margin of error, right? What if I asked the 30 people in this class? Is that better than just one?
Yeah.
Is there still error?
Yeah.
Is it more or less than before?
less.
Less. Okay, so how much error is okay?
None.
No error. I'm not.
What if I didn't have? I have my business. I don't have a lot of time. Do I have enough time to ask 1,300 kids what their shoe size is? No, I don't have that
Then
time.
maybe you should
Make like
wait. should wait to
Like a
drop your
website
shoes.
to have.
I don't have the time or the money for that. You
Why
see what I
not?
mean? So where's the trade-off? I have to figure out what's the margin. That's what we're going to calculate today, okay? And we're going to learn how to read a report, well, be able to analyze a number and figure out if it's a reasonable number, okay? So the next thing I want to talk to you about is, or here are the steps. If you're on the video, this is what we're going to work on is margin of error. So pause the video here and write this down. Okay, so law of large numbers. This is a statistical law, so it means like the variation of a data set decreases as the sample size decreases. Oh, it's supposed to say increases. What is this? Typo. My bad. Sample size increases. Increases. My bad. There's the error, right? Increase. Okay, so just like earlier, the sample size of one student's shoe was there's a huge margin of error, but the more numbers that I sample, the less error I get, okay? So the bigger the sample, the lower the error is what that's saying. Okay, so here we go, numbers 1 and 2. All right, let's pretend it's Trump and Hillary. Okay, let's go back to November, okay? A poll. So in the newspaper you might see, like the LA Times will say, here we took a poll and this is what we found. A poll reports that 56% of voters favor candidate B, and let's just pretend this was, what do you want it to pretend? Trump or Hillary?
Trump.
Okay, Trump. A poll reports that 56% of voters favor Donald Trump with a margin of error of plus or minus 3%. Okay? And what they're saying is that 56% of people like Trump, but there could be as many as 59% of people that like Trump and as little as 53. There's this margin that's there. We could figure out how many people did they survey, okay, using this formula. So just to get an idea, let's think about how many total voters are there in the U.S. or how many people could vote approximately.
Everybody's 18 and over, so probably like 16 billion.
No, there's not even that many people on the earth.
6 million.
Too little.
16 million.
We're in like
Too low.
almost 100 millions, right?
Yeah, you're probably like thinking about 100 to 200 million. Well, there's like 350 million people or population here, I think. So voters, let's just say everyone could vote, okay? 350 million. Okay, y'all thinking about the number? Is that a lot or little people?
That's a lot.
That's a little. Just kidding.
Okay, it depends what you think, right? But it's a lot of people, right? So I want to figure out how many voters did they poll. Here's the formula, we can figure that out. So you could use this margin of error. You could write this down. Please write what I'm writing down right now. So you have it in your notes so that when we take a test or a quiz, you know how to do it. So there's a margin of error formula, and that says we can find the margin of error by taking 1 over the n. And our n in statistics is how many people we sample. N is the sample size. Okay? So in this case, we don't know what the sample size is, but we know the margin of error is 3%. I could write a margin of error by writing it as a decimal as 0.03, and then that's equal to 1 over the square root of n. And then I could solve for n. I want to figure out what's n equal to. So I'm going to have to move this denominator over to the left so it's not in a denominator by multiplying it on both sides. And then I want to isolate the n by dividing by 0.03 on both sides and then squaring both sides. So n is equal to 1 over 0.03, all of that squared. Okay?
Is that 3% the amount of people that they didn't survey?
No, 3% is the margin of error, meaning like there is 3% error on the data, meaning there could be, it's reporting 56% of people like Trump, but there also could be 3% more that like Trump. So 59% of people like Trump. It could be. Or it could be.
They picked like an in-between kind of.
They're saying 56%, we think 56% of people like Trump, but we have a 3% margin of error, which means maybe 59% of people like Trump, or maybe 50.
Okay, so they didn't like directly survey, it's just like an estimate?
Yeah.
Okay.
Yeah. Well, they did directly survey, but they're estimating for all of the U.S. based upon a sample size. Okay.
So it's like a small mini survey, and then they make the bigger survey best off.
Exactly, and we're going to figure out the sample size. That's the goal right now. So let's get our calculators out. You can use your phone if you like. Let's do PEMDAS here. What's 1 divided by 0.03?
3
What's 1 divided by 0.03? Good, 33.3. Now we have to square it, so let's find that square button and square it, please. What did you get? Good. 1,111.11. That's our N, meaning, remember how Braden's all like they surveyed people? This is how many people the LA Times surveyed. They called 1,111 people. Okay? Is that a lot of people to call?
Based off of the population.
Based off the, good. What was our population of the U.S.?
Like 300.
350 million, right? How many people did the LA Times call?
1,111.
Okay, so they're like, hey, they're like, who do you like? Hillary or Donald? Donald. Next person. Hi. Hillary or Donald? Donald. Next. Hillary or Donald? Hillary. And they did that 1,111 times, and they figured out 56% of the people liked Donald Trump. Okay? Based upon that, though, there's a 3% chance that, or margin of error. So what does that mean? It means that there could be, if we know 56% of people like Donald Trump, since there's error in our data because we didn't sample everyone, we didn't do a census, there could be up to 59% of people that like Donald, or there could be there could be as little as 53% of people that like Donald. Does that make sense? There's a margin, right? We don't know exactly, but the margin of error is 3% in each direction. Does that make sense?
Yeah.
It's kind of analytical. And this is really important because when you read a newspaper and they're like, hey, you know what? Those Raiders, 70% of people like the Raiders over the Broncos. Okay? Okay, 70% of people, but then they're like, hey, there is a 20% margin of error. What does that tell you?
It's a big
Huge error, right? They're saying, hey, there are like, it could be as little as 50% of people that like the Raiders.
50-50 ratio.
Yeah, 50-50 ratio at that point. Then it's all like, this is bogus. Someone is just writing this because they want to prove a point. Okay? Let me do number 2 now. A survey of 2,580 students found that 9% are left-handed. So let's just say our high school is twice as big or over twice as big, okay? And I was like, I really want to know all the left-handed students. So I went to each student here, one by one. I didn't go random because I know I'm going to ask everyone, okay? However, I asked people today, and some people today are suspended, or they're absent, or they're out on athletics or a field trip, okay? So I couldn't ask everyone, but I asked most people. I asked 2,580 students. And I said, left-handed or right-handed? Left-handed or right-handed? Left-handed or right-handed? I asked each student that, okay? So I figured out 9% of students are left-handed. So what's my margin of error, okay?
Is it 50?
So I'm going to start with my margin of error formula. Okay, the sample size here is 2,580, so I'm putting that into my denominator. Okay, and then I go to my calculator. I want to figure out what's the square root of 2,580.
50.79.
Okay, and then I'm going to do 1 divided by that, which is going to be 0.0196 or 196 ten-thousandths, or 1.96% is my margin of error. And what does this mean? Okay, this means I figured out 9% of people are left-handed. Okay, right? So I know that there should be 9% of people that I asked are left-handed. I know that for sure, but I didn't ask everyone. I couldn't ask the people that were suspended, that were absent, that were on a field trip, or they were on some extracurricular activity, right? So there's a chance that those people might sway my data. So since I didn't ask everyone, there's still some margin of error. So the margin of error is 1.96% up. So 9 plus 1.96% is 10.96%. Okay? And then 9 minus 1.96 is 7.04%. Okay? So, and when I multiply these, that means there could be as few as 182 kids that are left-handed and up to 283 kids that are left-handed. Does that make sense, everyone? This is just analytical. So, and when you know this stuff, you could be more critical of what you read. Like a newspaper, they might say, like next time you might vote, in 4 years you're going to get to vote again. Well, hopefully you'll get to vote. You'll read the newspapers, they'll say, hey, you know what, this candidate is favored. They have a 51% lead over the other. But then they're like, there's a 5% margin of error. So that means that they might be lying because there could be as few as 46% of people that like that candidate. So, yes?
If you're an ex-convict, can you vote or no?
An ex-convict?
Not like you're a criminal.
Good question.
If you are, I think if you're free from the jail system or prison, you're allowed to vote. I think so, yeah.
No, if you're on parole, you can.
Oh, you can't? Oh, okay. I didn't know that.
Do we always have to write that little graph thing, or is that
No.
just for our...
That's just so visually you can see what that means.
So we would just do like the 1.96%?
That's it, yep. That's your margin of error. Okay, that concludes the lesson.